Hello everyone, hope you all are doing well. So in this video we'll discuss the last problem of Leetcode Weekly Contest 355. It's a hard level problem and I would say harder than the other level 4 problems that you get. So this problem contains 8 points. So yeah, let's see. It's a very good problem to solve and let's see what it is asking us to do. The problem name is count paths that can form a palindrome in a tree. Okay. So you are given a tree that is a connected undirected graph that has no cycles and that is rooted at node number 0. It consists of n nodes numbered from 0 to n minus 1. The tree is represented by a 0 indexed array, parent of size n, where parent of I is the parent of node I. Since node 0 is the root, parent of 0 will be equals to minus 1. So this is the info that we have, that how the tree will be given to us, right? Then you are also given a string s of length n. S of I is the character assigned to the edge between I and parent of I. S of 0 can be ignored, okay? Return the number of pairs of u comma v such that u is less than v, and the characters assigned to edges on the path from u to v can be rearranged to form a palindrome. A string is palindrome when it reads the same backwards as forwards, okay? Big problem statement. Let's see what it is asking us to do. Look, this is how the tree is represented, right? These are the indices 0, 1, 2, 3, 4, 5. Indices, node number, whatever you call it, okay? Node starts from 0 to n minus 1. These are the number of nodes. So this value tells that node number 0 has a parent minus 1. Now since it is rooted at 0, it doesn't have a parent. Simple. Also ignore the first character. Then node number 1 has node number 0 as parent. Node 1 has node 0 as parent, and also that particular edge has a character C. Great. Node number 2 has a parent 0 and the edge has a character A. Just see, 2 has a parent 0 and character A. Then again node number 3 has parent as 1 and character is A. Great. Node number 4 has parent as 1, character as B. And then node number 5 has parent as 2 and character is C. Right? This is what the tree looks like. Now we have to tell how many u comma v pairs are there such that whatever are the characters on the edges, right? For example, if you move from 3 to 0, just taking an example, what are the characters that you get? You get A and C. Now we have to tell that can we rearrange these characters to form a palindrome or not, right? So we have to tell the count of these pairs, right? For every possible combination, right? Like in this case, suppose I take 3, 1, 4. So the characters are A, B. I cannot form a palindrome. Let's take 1, 0, 1, 0, 2, 5, right? That means 1, 2, 5. So this will be the path 1, 2, 3. So C, A, C. Yes, it is a palindrome, right? I can rearrange it. Instead of this, if it would have been C, C, A also, then also I would have rearranged it to form a palindrome. What's the condition of a palindrome? That at max one character should have odd frequency, right? At max, you don't need to know the exact frequency, just the parity will work here, right? That means whether the frequency of a particular character is even or odd, right? And we have to find all the pairs. This is what the problem is asking us to do. Now let's see the constraint, right? By the way, for this example, all the single edges will be palindrome, right? A single character is always a palindrome. So yes, these are the 5 pairs. And what are the other pairs? Just see. 2, 3. So 2, 3. A, C, A. Yes, a palindrome. Then 1, 5. So 1, 5. C, A, C. Great. This is also a palindrome. Then 3, 5. So 3, 5. It is A, C, A, C. Just rearrange it. You can form A, C, C, A, C, A, A, C, whatever. It doesn't matter. What is the exact palindrome we are forming? We are not concerned about it. We are only concerned, is it possible to form a palindrome or not, right? So that's it. So one more thing to remember, 3, 5 we have taken. We have taken the path from 3 to 5. Now you will not consider the path from 5 to 3, right? One node should be less than the second node. So you have to consider every pair only once. That's already mentioned in the problem, right? So this is all about the problem statement. Let's look into the constraints. The constraints are the number of nodes that you can have in your tree is 10 raised to power 5. That means I cannot just iterate and generate all the pairs. No, that is not at all feasible because this will time out. So now what's the second possibility, right? Can I hold some information, right? Can I see some observations which can help me in solving the problem. So let's just check that, right? Let's just check that. So let's consider some node. Suppose this is a node. Let's call it, this is the root node. Let's call it, this is root node A. This is node B. This is node C. Okay. Now we will only see the parities. Why? Because we are not concerned about the frequency, right? Someone is not asking me to generate the exact palindromes. I just have to tell whether I can make a palindrome by rearranging or not, right? So I can just keep some information like this. What are the possible characters I have? I have characters from A to Z. That means 26 possible characters are there. Now there could be multiple ways for storing this information as well, but bit masking is an easy way. So we'll go step by step. Consider you have 26 positions, right? Each representing a single character. Like for example, the first character represents A, then B, then C, then D, then E dot 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 till Z. Okay. This is what it represents. Now, if a particular character is 1, I mean if a particular unit is 1, for example here, if C is equals to 1, then this will tell me that, okay, the frequency of C is odd, or the parity of this particular character is odd. If the parity of a particular character is even, that will be represented by 0. Simple. This is some basic information that we should have. How we'll get this information, that is different, but this is how we will be representing the values, right? Also, these are only 26 bits. I can just take an integer, right? An integer is 32-bit. So I can use 26 bits to keep this information, right? So it will be sort of a big O of one space, right? So this is something that we will do. Now let's start, right? Let's start. So suppose this is the root node and this is B. So when I start traversing from this root node and when I come to B, so what's the path in this? When I come to B, it's root to A plus the path from A to B. In short, the characters that I encountered from root to A, there could be multiple intermediate nodes, but for simplicity, I've made this diagram. So the characters that you encountered from root to A and the characters you encountered from A to B. This is the total characters that you got from root to B. Simple. Similarly, when you came from root to C, it was actually root to A plus A to C, right? This is the path from root to C. Getting it? Now. At this particular node, at B, how we are storing, forget about that. At this particular node, if somehow we store the parity that, okay, for these 26 characters, right? If I go from root to B, these are the parities of the 26 characters, right? I can just take an integer to store it, right? We have already seen it. So again, to reiterate, from root to B, I go, and at this node, I just store that what's the parities of all the 26 characters, right? For which path? The path from root to B. If I just store it. Similarly, if I store what's the parity of all the characters in the path from root to C, if I also store it, right? Now, just see one thing. To take a concrete example, suppose here I store that all the characters came even number of time except one character, and let's call that character as D. It had E odd parity. Doesn't matter. Maybe it came 1 time, 3 times, 5 times. That doesn't matter. Here also, suppose all the characters came even number of time except this character D. Alright. Now, equality of these two values means that the parity from root to B and root to C for all the characters is equal, right? Now, just see one thing. If I remove this path, if I remove root to A, then what are the possibilities? What can happen? Just see here. All the characters which have even frequency in this value for this node, the same characters, the same set of characters have even frequency for this node as well. Maybe A came here 2 times, but A came here 0 times. What I mean to say, the set of even frequency characters here and the set of even frequency characters here are same. Similarly, the set of odd frequency character here and the set of odd frequency characters here are same, right? Now, if I remove this thing, then the parity could change. Maybe a character which was probably occurring 2 times, right? So from here to here, A was occurring 2 times. Maybe one A was contributed from root to A. So what will happen if you remove this path? What will happen? this one A will be removed, and ultimately the parity of A will change, right? The parity of A will change. Initially it was even, now it will become odd. But the same thing will happen with this node as well, right? Why? Because root 2A is having root 2A. This path is having a node A. Now, here initially A was coming even number of times. Here also A was coming even number of times. Now you removed 1A, this became odd. Similarly, you are removing 1A, so this guy will also become odd. That means they change in pairs. If something is even here, that thing will remain even here. Getting it? Because you are removing the same set of characters, right? You are removing the same set of characters because there is a path common. Which path? This is the lowest common ancestor of root B and C. So root to lowest common ancestor are the common characters which we are removing from both the sets. Okay, from both the sets. So what happens? Something which was even can become odd, but it will become in both of the nodes, right? In both of the nodes, you can just check it. For example, A was coming, suppose 5 times. If you remove one occurrence of A, it becomes 4. But here also, it should have been coming at least one time, right? Suppose there was no A here. So A will also be, what do you call it? Odd, will be coming odd number of times here, right? Remember, this condition is true when I'm saying that the initial parity for both of them is same, right? Initial parity is same. That means A comes odd times here, A also comes odd times here. Why I'm taking this into consideration? I'll come to that point. But suppose this is true. Both of them had the initial parity is same. Then if you remove this common path, they will again have the same parity. I mean, both will have the same parities. Maybe that changed. Maybe A becomes from even to odd here. Then since it was even here, it will become odd here as well, right? Because the parity of this A is changing by removal of this path. So removal of this path will affect the same set of characters in this also, and hence the parity here also will change, right? Simple. So this is something that we can do, right? So we have calculated the values or what are the for every characters, what is the parity from root to a current character, root to a current node. This is something we have done. Now just consider this. If this node and this node, or rather consider any two random nodes, if one node and the other node, they have the same set of parities, means same set of characters occurring even number of times and same set of characters occurring odd number of times. What do I mean by this? Suppose A, B occurs odd number of times in this and also in this, and rest of the characters occur even number of times. So can these two combine to form a palindromic string? Yes, they can. Simple, right? Because this is even set, so I can place them like this, and this was odd set, but odd set is also coming 2 times. So 1A from here comes here, 1A from here comes here, 1B from here comes here, 1B from here comes here, right? No, right? So when they are same, so this is what happens. You are able to form a palindromic substring. Again, let me reiterate. First, consider the nodes. First thing, calculate the values for every node. Which values? That what's the corresponding parity of each character using an integer. Second thing, if I just consider 2 nodes, then I can simply remove the path from root to their lowest common ancestor, and hence their corresponding for that pair, the parity will change together or it will remain same together. So ultimately they will be same, right? The parity will remain same. All the odd numbers, all the odd parity will remain odd, or maybe if they become even in one node, that will become even in another node also, if their initial parity is same, right? So now what I mean to say, you can form pairs of all the nodes which have same set of combination. Which same set of combination? A to Z. Suppose B comes odd number of times, C comes odd number of times, X comes odd number of times. Now if you have any other node also which had this configuration that B, C and X are coming odd number of times, doesn't matter what's the exact frequency, maybe 1, 3, 5, 7, anything, XYZ, but ultimately if they have the odd frequency, same set of characters having odd frequency, these two can form pairs. So if I have total n values, which have the same parity, then how many combinations can I form? Simple. 1, 2, 3. 3 numbers are there. Suppose 3 nodes have the same value. So this guy can form a pair with this and this. This guy can form a pair with this. So total 3 pairs, right? So for n, it will be n into n minus 1 by 2. So for 3, it will be 3 into 3 minus 1 by 2. Getting it? This is the first part where the parity is same, right? I hope you got this point, right? When the parity is same, what happens? Now, what's the other case? In a palindrome, what did we discuss? That we can have at most one, what do you call it, one character having odd frequency. Now here we were considering the combinations where though they were having odd frequencies at individual nodes, but when you combine two nodes having odd frequency, their parity becomes even, right? Simple. So all the strings that we have considered till now were even length string, but I can have odd length string as well. So now what can I do? Let's again see that. Suppose for a particular node a b c dot 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 something like this, d is coming, d is set, that means d is coming odd number of times, and suppose x is also coming odd number of times, right? X is also coming odd number of times. Now just see one thing. Sorry, I can also consider the numbers, or I can also consider the nodes which have a different parity for only one character, right? How that will be helpful, I'll tell you. But what do I mean by this? Suppose there is a node A which with this configuration that d and x are occurring odd number of times. I have another node B which have all the characters same, I mean all the characters have same parity, except suppose d is occurring, what do you call it, even number of times, and only x is occurring odd number of times. That means the only difference that you have in these two nodes is this: in one, x is occurring odd number of times, in sorry x is same in one, what do you call it, here d is occurring odd number of times and here d is occurring even number of times. Okay, that's the only difference, otherwise all the configurations are same. So I have only one character which have different parity. Now can I use this combination? Can I use this combination to form pairs? Let's check that. Just see, the parity of these are same, all the characters are same. So I am not concerned about the frequency. Maybe here a comes 2 times, here a comes 0 times, but ultimately whatever is the total sum of frequencies, half of them can come here, half of them can come here. I mean starting of string, ending of string. Similarly, half of the total frequency of B can come here, dot 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 dot, everything except this guy. The parity of X, sorry, I'm really sorry. So parity of D, the parity of D here is, what do you call it, odd, and this is even. That means the total number of occurrences of D when I combine these two is odd. So that means that remaining odd element can be placed in the center. Maybe here D comes 3 times and here D comes 2 times. So total I have 5 occurrences. So 2 D's can be placed here, 2 D's can be placed here, and the last one can be placed here. What I mean to say, if there are two nodes which only differ in parity of one character, then they can also form a combination, because that odd one out character can be placed at the center. These will generate odd length palindromes, right? What are the cases? The first case that we discussed was even length palindromes, where the parity of all the characters were same. So half of them placed here, half of them placed here. So every character is same, sort of a mirror image, right? But here, and mirror is at the middle, right? Here, again, it's a mirror image, but mirror is here where it is basically hiding one of the elements, right? This one is the different element, odd length palindromes, right? So what I can do is I can pick up the values, right? I can simply pick up the values. Which values? Suppose A had this parity. A had this parity where D and X were where D and X were coming odd number of times. Now what I'll do is A, B, C, D dot 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 till Z. What I'll do is I'll pick this value, right? I'll simply pick this value, and now what I'll do, I'll check that this is the parity that I have. But now let's consider the nodes which have parity difference at only one position. Why are we considering that we have already seen. Now how do I see that? So suppose the parity here is even. So I'll find the count of nodes which have this parity as odd, and all the other parities are same as this. Simple. Again, now I'll consider B. It's the same node. Now suppose the parity of B is even again, right? So what I'll do, I'll consider all the nodes, or rather the count of nodes where B comes odd number of times. All the other characters, all the other 25 characters have the same parity. It's the the only difference is at B. So I can consider it for 26 possibilities because I have 26 characters, right? So now what will happen? Suppose the number of occurrences of this parity is n, because the number of nodes can have the same combination of parities, right? So suppose that is n into, if I consider that the number of nodes which have only parity difference at A, okay, only parity difference at A. So what I'll do, suppose those are m, so n into m combinations are made. Simple. All right. So we do it for A, we do it for B, we do it for C, and so on. Simple. We do it for everything and so on. Now you must be thinking that here we are counting every node twice. I mean, if node A and B were forming a pair, then B and A are also forming a pair, and we are adding everything twice. So all you need to do is you just need to divide the answer by 2, because you have counted everything twice. In the initial case also, the first case where we were generating even length palindrome, there also we counted everything twice, right? Sorry, there also we counted everything twice. Here also we are counting everything twice, right? So all we need to do is whatever is the total answer, just divide it by 2. Now comes the logic. How do I check this? That find all the characters which have a different parity at A. Simple. As I said, I have 26 bits, right? In integer, I have 32 bits, but I'm using only 26 bits to represent the parity of each character. At A, if it is 0, I want to make it 1 to check, right? And if it is 1, I want to make it 0. I just need to flip one bit of a particular integer. Now, what's the most popular operation to do that? XOR, right? XOR, because if you have some bits and here it is 1 and you want to just flip it, you XOR with this value. Every position is 0 except this one. So this 1 becomes 0. Similarly, if you had 0 here and if you just XOR it with 1, it gets flipped to 1, right? Simple. So there are multiple concepts involved in this question. All we need to do is we need to discuss it individually and then just combine that logic, right? The code is very small. Let me just walk you through the code, and this is very small. You can just see that. So just see, this is the function, right? And here what we are doing, we are constructing the graph or tree, whatever you call it. How we are constructing, just see. For all of them, I'm just keeping account that whatever is the parent, like for example, in this case, 1 will have entries 3 and 4, 0 will have entries 1 and 2. So parent will keep entries for its child nodes, okay? Simple. So graph.put if absent, if the current parent is not existing in your hash map, insert a new array list and then add the current child node there. This is basically the construction of graph. Simple. Now I call it DFS. I just do a DFS because I want to calculate that bit mask value for every node starting from root node. Because if I remove something, as I told you, if I have to consider any 2 nodes, I'm removing a common path, that is root to the lowest common ancestor. Maybe that goes via root. Like for example, here it goes via root. That won't make any difference, right? So let's call the DFS function. So this is the current node I am considering, the current mask, because I don't know the parity of any character till now, and this is the string S. Remember, every character represents the, what do you call it, the character present between the current node and its parent and so on, right? Now let's do that. So this is the graph, and this is the this is another map that I've taken. So this is the mask, and how many integers, how many nodes have this particular mask, right? The count, basically the count. So that's what I've done. This is the mask, node char parity dot put mask node char parity get or default 0 plus 1, meaning just increment the frequency by 1 because one more node has this mask. Simple. Now you have done it. Now you'll go to its child nodes. Let's go to that. Graph.get or default current node or array list. Simple. Whatever is the child nodes, return me, or else return me a new array list. You can do that by doing a if else condition as well. I've just tried to avoid it. Now what's the new mask? Okay. Now what's the new mask? So just see this. Whatever was the mask I had, right? Whatever was the mask I had, I will also include the current character there. I'll also include the correct character here, right? Now what's the current character? Just see. This is the child node that I have, right? For example, 0 is connected to 1. This is the child node. So this particular character, this particular index will have the character that is present here, right? So s.char of I minus, simple. Char at I minus a. What does this mean? So in the examples I've shown you, it's A, B, C, D like this. in reality it's like this, right? This is how we implement. So the 0th bit will represent the frequency of A, the first bit will represent the frequency of B, not frequency, rather parity. So here what we are doing, let me just erase it to make it more clear. Whatever was the mask, whatever were the parities of the characters till now, I am just tweaking the parity of one character because one extra edge is being added, right? Which particular character is being added? Whatever is the character minus A. So if it's B minus A, that means the first character. So one left shift one, that means you come to this position. Simple. You come to this position and just take XOR. Why we are taking XOR? Suppose till now the parity of B was odd, it should become even. So I'm just flipping it. If it was even, it should become odd. I'm just flipping it. Simple. This is the new mask. Now this is the child node, this is the new mask, and this is the string. So basically this DFS code will find the value of masks for all the nodes from root node. Okay. And it will just populate the hash map with those values, right? So after populating the hash map, it will be like this particular mask is present with how many nodes? This count of nodes, right? This is the purpose of DFS. Now let's compute the answer. Answer is equals to 0. Let's traverse our map. Okay. This is the current key. I mean, this is the current mask. This is the number of nodes having that mask. Now, nodes having same parity of characters. That means even length of palindromes, right? The first case that we discussed, what we'll do? Current frequency into current frequency minus 1, right? Remember n into n minus 1 by 2? That's what we are doing. The current mask is being held by these nodes. So these nodes into these nodes minus 1. Now, for all the 26 characters, we have to check that how many nodes have the same parity for all the other characters except for one character at a time. I have 26 characters. Let's do that. This is the frequency of, this is the number of nodes having the current mask. Now just tweak the mask. Node char parity dot get all default. Whatever is the current mask, take an XOR with the current character. Remember, initially, if I want to tweak the parity of A, it will be 1 left shift 0. That means don't do it. Then 1 left shift 1 for B, 1 left shift 2 for C, and so on. So 1 left shift I. First to do it for A, then B, then C, and so on, right? So get all default, simple. These nodes have the current frequency, and these nodes will have a frequency where it only varies, where the parity only varies for the ith character. Remember, odd length wala palindrome that we are making. Finally, you just add that in your answer and you return answer divided by 2, right? So this is how you solve this problem. There are a number of observations in this problem, and I would say this is a hard problem, right? It actually is a hard problem, but yeah, a very good problem to solve because you have to apply a number of concepts here. So yeah, that's it for this solution. It took time for me to solve this problem, but this was a great problem to solve, to be very honest. And yeah, I hope you learn a number of new things from this video. So do support it by giving a thumbs up, do subscribe to the channel. In case you have any issues related to the solution or any queries, mention that in the comment section. I'll revert on each one of them. Thank you. Take care. Bye-bye.